Okay, today we're going to learn about 6.3. It's called definite integrals or antiderivatives. Forgot the I, so anti, sorry. We're going to do a worksheet instead of a book assignment. You can either follow along at my notes or you can write in your notebook. It's up to you. Okay, the first definition is if you're integrating from a to b f of x dx, if you want to flip the limits, do you notice that I flipped my limits? If you flip the limits, you need to put a negative sign in front. For example, let's say we're integrating from 2 to 0 x dx. And you know that you usually should have the top number on the top, or the bigger number, I mean, on the top. If you want to switch these around so it looks like you've seen in other sections, if you want to flip the limits, all you have to do is make sure you put a negative sign in front. So it is smaller number on the bottom, bigger number on the top. Really important formula. Don't ever forget it. If you want to switch the limits, you need to put a negative sign out in front. Okay, the next one, it's a really quick one. Whenever you integrate from a 3 to a 3 some x dx, the area is going to end up being 0 if you're only integrating from 3 to 3. If you're integrating from the same spot to the same spot, you're not going to find the area. Okay, the next one is another important one. K stands for constant. Remember the rule that I said about deriving constants? Do you remember that rule? The rule is to just carry the constant along to derive. Same thing with integration. If you see 3x to the 4th dx from 0 to 2, if you don't want the 3 in there, you can take the 3 out and only derive the x to the 4th. I don't know why you would do that in this situation, but you will use this. It doesn't seem like you would want to use it, but you're going to use it as time and time until we get into the harder problems. So make sure you know. All you would do then is integrate this, find the area, and after you find the area, multiply it by 3. Okay, the next one, the fourth one, says that if you have two different functions underneath the same limit, you can add or subtract. If you want to split them up, you can split them up into two different area problems and integrate them separately under the same limit. For example, let's say you're going to integrate from 2 to 5 x squared plus 3x dx. And I don't know why you would do this, but maybe you want to split them up and just find the limit of just x squared dx from 2 to 5. And then also find the area from 2 to 5 of 3x dx. And then find the two areas and add them together. It's just another property. The next this is just important for the next section, 6.4. This is just very important that you understand that your limit, which is x, cannot have the same variable as your function. This can't happen. This can happen is this. If this is a variable on top, we won't deal with variables until the next chapter, so I don't know why, or next section, I don't know why they're showing you this right now, but keep this in mind. I'll talk about it again in the next section. These two, they can happen because the x and f of t are two different variables. But don't worry really about number 5 until the next section. I'll talk about it again. Okay, number 6 is really important, and I'm just gonna do the explaining. So let's say you integrate from 1 to 2 some function, and then you integrate again from 2 to 5 the same function. Wouldn't it just be easier, just instead of integrating from 1 to 2 and then again from 2 to 5, wouldn't it just be easy just to integrate from 1 to 5? So basically that's what this says. If you integrate from 1 to 2 and then you integrate again from 2 to 5, why don't you just integrate? So basically these two need to be diagonals of each other. And if they are diagonals of each other, then you can integrate from the lower limit to the upper limit by taking away the 2's. I hope you understand that. I'll do an example for you later on in the notes. And the last rule is this. If you're integrating from 0 to 3 and some function is like 1 over x minus 2, and you're going to multiply it by g of x, which is natural log of x dx. So basically this stands for f of x and this stands for g of x. Just a reminder, don't assume. There is no rule. It's not necessarily true. This is what you can't do. You can't just integrate from 0 to 3, 1 over x minus 2 dx, and then multiply it from 0 to 3 natural log of x dx. You can't break this up. You can break up, go back up here, you can break it up if it's positive and negative. You can assume true for that. You cannot break it up for products and quotients, or multiplying and dividing. This is not necessarily true. This is not necessarily true. So do not break it up. We show you a different way how to solve problems like multiplication or division. The product and the quotient. So just remember you cannot break up product and quotient and just assume you get the same answer. Okay. The mean value theorem, and here's the definition. If f of x is integrable on a and b, then its average value on a and b is 1 divided by b minus a f of x dx. So, on page 291 is this problem right here. The reason why I want you to go to page 291 is to look at the picture. And I'm hoping you understand it if you look at the picture. If you don't look at the picture, you might not understand it. So they want you to find the average value. So they want you to integrate this 4 minus x squared dx from 0 to 3. But they also want you to find the average value. So you have to remember 1 divided by b minus a. B is 3, a is 0. So just really quick, this ends up being 1/3. I showed you how to integrate this. I'm just going to tell you it's 3 right now. I think the next template, I show you how to get 3. So just assume it's true. Assume that it's a 3. And you get 1 for your answer. What does that mean? It means it's the mean value theorem. Okay, what that means is that's called the mean value. And if you look at the picture on page 291, you're going to see that if you set this equal to the actual problem, 4 minus x squared equals 1, this magical one that we just found by finding the mean value, and you subtract 4, you get negative x squared equals a negative 3. So x squared equals 3. So the square root, x equals plus or minus the square root of 3. But we're only integrating from 0 to 3, so x is only going to equal the square root of 3. If you look at that picture on page 291, you're going to see this little magical number, x equals the square root of 3, in the picture. And you're going to notice that in the picture, that exactly at the square root of 3, that the top and the bottom areas are equal to each other, and that's why this is so important. Again, I'm going to do another one on the next couple of templates later, so you'll understand how to do the mean value. Okay, the antiderivative formula, I've already talked about this. On 6.2, I kind of got ahead of the game here. Basically, when you integrate the 4, which is 4x. You integrate the x squared, which is x cubed over 3. you added 1 divided by 3. Everybody knows how to do that. You make a straight line and you put 0 to 3. And all they're saying is this is the formula to find the derivative. The big F stands for the antiderivative. So this stands, 4x is really the big F, and then x squared, x cubed over 3 is the other big F. And you take the top minus the bottom, so you plug 3 in both spots, which only means that's the 3, and now you have to subtract it from the 0, and you plug 0 in now. And you're going to end up all this canceling out. So 12 take away 9 is equal to 3 units squared. And that's how you find the antiderivative, or, really important, this is how you found the area under the curve. Okay, next part. Okay, we're going to use those definitions that I gave you at the beginning of the first template. So I just want to go over a couple of them. Okay, let's see if you guys know your rules, your little definitions that you just learned on integration. So, here's the first one. Do you notice that there's a little -2 here? The rule says you can take it out if you want to, and leave the rest of the stuff alone. And this part right here, if you look up above, one of those looks like that. And doesn't the first one look like that? And so in place of that, can't you just put a -1, which stands for the first one, which means that's the area of the first one from 1 to 9. And a -2 times a -1 equals a +2. Final answer. All we're doing on this template is learning the definitions that I gave you on the first one. Okay, the second one, sorry, I forgot my dx. Bad. Okay, all it says is the next property is separate them. 9 to 7 h of x dx minus 9 to 7 f of x dx. Remember the definition? You can separate adding and subtracting, but you cannot separate multiplication and division. You'll know why, like I said about multiplication and division. Look up above, and do you notice that this one right here is the middle one? Look up above and look to see. But what's the difference between the boxed-in one and the middle one that is given? Do you notice that the limits are completely switched around? So if you want to switch them, remember what I taught you? If you want to switch this to a 7 and this to a 9, you need to put a negative out in front. So really, the answer to this is not a +4, but a -4. See how that works? And same thing for the second one. Do you notice that the second one, I'll circle it or box it in so you can see. Do you notice that the second one is similar to the third one up there? And you notice that the third one, again, aren't the limits completely switched around? So if you switched around, if it would have been that, it would have been a -5. But since you're switching it around, and this is supposed to be 5, if you switched around, isn't 2 negatives going to equal a positive? So, basically, you need to put a negative sign out in front, and you need to flip this to a 9 and to a 7. But if you flip it, these 2 negatives equal a positive now. So instead of subtracting, you're really adding, and now it looks like that. So now it looks like +5, which ends up equaling a +1. See how this works? You notice how important switching limits and changing the negative sign does. We did it in the first one and the second one. Oh, I guess we did it, just the second one. Okay, the third one. Do you notice that from 1 to 7 f of x dx is not up there? Do you notice that? Really important. But what we're going to do is use the first and the third. We're going to use the first and the third to help us get the answer to that. Okay, so I'm going to write down the first one. The first one is 1 to 9 f of x dx plus, I'm going to write down the third one, and the third one is 7 to 9 f of x dx. Okay, so I wrote down the first and the third. We want to integrate from 1 to 7. So let's see if you guys remember what you need to do. So let's go back to the definitions. I want to go back to it, and I want to go back to the special one. And here I'm going to talk about it one more time. If I integrate from 1 to 2 and then the 2 to 5, isn't it easier just to integrate from 1 to 5? Wouldn't it just be easy just to integrate from 1 to 5? But how does this need to be set up? Do you notice that the two numbers that are the same, the 2 and the 2, need to be one on top and one on the bottom? And then you can integrate from 1 to 5. So let's go back to this page, which is right down here. And let's set this up so that we can integrate from 1. So I'm going to leave this 1 to 9, f of x dx. I'm going to rewrite the third one. And I'm going to flip the 9 and the 7. You notice that when I flip the 9? Sorry, I did not flip the 9 and the 7. I thought I did. I said I was going to do it. The 9 goes here and the 7 goes here. Okay, remember I said that these two numbers need to be diagonally of each other. Are they diagonally of each other? Then what you're going to end up with then is 1 to 7 f of x dx. So those two on top equal this on the bottom, but I forgot to do one thing. Did you catch what I forgot to do? What I forgot to do is my first one was identical, but my second one wasn't. I flipped my limits. If I flip my limits, I need a what out in front. So I'm hoping you caught that. So now I can come up with my final answer. And my final answer is, I'm not going to use this. I'm going to actually use this. And that box in, what was that? I think it was, yeah, it was a -1. And then I'm going to go and use this. And if you go look up there, I have 7 to 9. I don't have 9 to 7. But my 7 to 9 up there was 5. So that makes that boxed in area a -5. And when you add the two together, you're going to make a -6. And what does a -6 stand for? It stands for integrating from 1 to 7, which would make sense. If one is a -1 and the other one was a -5, and you want to integrate all the way from 1 to 7, you would just add the two sections together, which would give you a -6. Okay, I think we are starting the parts now. Okay, sorry to say, but yes, this is part 1. I guess the first one was yeah, this is part 2, if you really care, because I just did the definitions. Go back to this. This was part 1. How to read definitions. On the worksheet, you'll see it too, that it's part 1. Okay, on the worksheet, part 2 is this. Can you evaluate without a calculator? So, all you're going to do is you are going to find the antiderivative of 1, which is x. You're going to find the antiderivative of x over 2. You add an extra 1. If you add an extra 1 to that power, that means you have to divide by that power. You can leave it as 2 times 2, or you can erase it and put a what down? 4. Remember I told you to draw a line and integrate from 1 to 2. Okay. Just to tell you, you can integrate from 1 to 2. Do you notice that usually the smaller numbers on the bottom and the larger numbers on the top, but in this case, do you see that they're flipped? It's your choice. You can leave it like that, or if you flip it, you can flip it if you want, but when you flip it, what do you have to remember? There needs to be a what sign carried down. So just keep in mind that if you flip it, you need to put a negative sign. Okay, I'm going to flip it just to show you. If you put a 2 in for both x's, minus, put a 1 in for all the x's, you're going to get 3 minus 1 plus 1/4 is 1.25, which is 1.75. Which is a negative. Don't forget to carry the negative. Okay, I'm just going to show you x plus x squared over 4, and I kept it 2 to 1. I'm just going to show you that if you don't want to flip it, you don't have to flip it. It's always top minus bottom, correct? Remember I showed you? So the top number is 1, and the bottom number is 2. You're going to get 1.25 minus 3, which still gives you a negative 1.75. I'm just showing you that if you don't want to flip your limits, you do not have to flip your limits. It's up to you. Some people flip their limits and forget the negative side, so it might not be a good idea to do it. Okay, the next section is very complicated, so you really got to watch what I'm doing here. Okay, the next section deals with integrating from A to B and noticing the difference between integrating and total shaded area. When you hear the word net area, you need to take into account that the first part is above, the second part is a negative, and the third part is positive. That's called net area. When you do total shaded area, do you notice that there are 3 sections? First section, second section, and third section. You need to take them all and make them positive, or basically absolute value is what those 2 little lines stand for. Absolute value. So, here is the problem, and this is one of the problems on the worksheet. But the problems on the worksheet, this is the one I don't have you doing. But basically, it's hard to see this. But basically, just draw this in. Color this in. They want you to find the area of the shaded region of 3 minus 3x squared from 0 to 2. Okay, so if you want to find the total shaded area, which means all positive, I need you to re-break this up again. If you don't know what it looks like, it doesn't hurt to plot points. You can watch me if you want. When x is 0, you get 3. When x is 1, you get 0. And when x is 2, you get a negative 9. So what does this graph look like? It looks like this. I'm just going to put this as a negative 9. It looks like a parabola. It's supposed to be rounded, but that's what it looks like. And what they want is this total shaded area right here. But this is where it gets confusing, so you gotta be listening. Ready to listen. This is very complicated for some people. Whenever you find the area under a curve, everybody listening? It's always from the curve to the x-axis. I'd write that down if I were you. It's always the curve to the x-axis. So, what I'm going to do is I'm going to find the area from the curve to the x-axis. Do you notice that that's positive? And here's where it gets complicated. Here's the curve, and I'm going to 0 to 2. Do you notice that this is the rest of the area? Curve to the x-axis. And remember what we're integrating from. We're integrating from 0 to 2. And that's why I stopped it there. But do you know the original picture? This is the original picture. But we're going to use integrating, and what we're going to do is this. You guys ready to go? We are going to integrate from 0 to 1, and the equation is 3 minus 3x squared dx. Now I want to hurry this up. Basically, I'm going to erase the 0 to 2. I'm going to integrate, and I'm going to get 3x minus x cubed from 0 to 1. And I'm just going to hurry this up, and the area is 2. What does that mean? That this little red area right here is 2. Okay, now I'm going to do the same thing, and I'm going to integrate from 1 to 2. 3 minus 3x squared dx. And I'm going to hurry this up again and get 3x minus x cubed from 1 to 2. And when I work this all out, which I'd have to sit and do, which is very time consuming, you're going to get a negative 4. So this stands for the red area, and this is going to stand for the green area. And you can tell that the answer should be a negative 4. But that's not the original picture. The original picture is the parabola. They want you to figure out the area of the parabola. So this is what you have to do. And this is why you needed to know geometry. So basically, do you notice that down here, I'll put it in blue, do you notice down here in blue that the blue area of the picture makes a rectangle? And if you take the rectangle and you subtract it from this little area that we found, it'll give you this part of the parabola. So this is what we need to do. We need to figure out the area of the rectangle. And it's not too hard to figure out the area of the rectangle. Do you notice that if you're going from 0 to 2, that the width is 2 and the length is 9? You're not going to use a negative 9 because you're trying to find the area, which is positive. Do you notice that this is 18 for the area of the rectangle? Minus the area of that little green part, which is 4. But remember, we're doing total surface area, so that's why it's a positive 4. So this part is 18 take away 4. This part is going to end up being 14. This is units squared. And this part right here is 14, and this little red part here looks like that is 2. So basically, what's the total shaded area? Which is the red area, and the new area, which, I don't know what we call that new area. Let's just make it black. Don't we just add the 2 together? So doesn't the 2 and the 14, isn't it 16 units squared? Do you see now why geometry is important? Where you're going to use geometry? And that's why you learned how to do the geometry part. And there's another spot on this template where you're going to use geometry. Okay, the next part. Let's just revisit mean value theorem again. Okay, just one more time. You haven't seen it since the beginning of the notes, so let's just review mean value theorem. It's 1 over b minus a, which is 1 over 3 minus 0. We're going to integrate from 0 to 3, a negative x squared over 2 dx. This is called the mean value theorem. The new thing is this. Mean means average. On the AP test, it might say average value or it might say mean value. They mean exactly the same. So, trying to hurry this up, 1/3, and I'm going to integrate this. Basically, you add 3, or add 1, which makes 3. If you add 1, you have to divide by 3, which makes 6. And I'm going to integrate this still from 0 to 3. Whatever that answer is, whatever this boxed in answer is, you have to multiply by 1/3. And again, I want to speed this up. And when I don't have this written down, but whatever this is times 1/3 makes a negative 3/2. You could plug that into your calculator too, but you're going to get 1/3 times whatever that number is, a negative 3/2. And then on the AP, they might ask you at what x value will the mean value equal a negative 3/2? And all you're going to do is take the original problem and set it equal to the area that you found, the mean value. And the original was, what was the original? A negative x squared over 2 was the original problem. The mean value was a negative 3/2. We have a proportion equal to proportion. Make these both positive. 2x squared equals 6. X squared equals 3. Square root. You're going to get x is equal to plus or minus the square root of 3. It just so happens that it's the square root of 3 again. And since we're only integrating from 0 to 3, it's the square root of 3. Again, at x equals the square root of 3 is when the mean value is going to equal a negative 3/2. Okay, next section, we have 2 more templates. They want you to integrate and they want you to find the total surface area or area. So let's define what integrate means. When you integrate, if you use your calculator, integrating is basically net area, which deals with pluses and minuses below and above the graph. If they ask you to find area, which is called total surface area, they're going to ask you to find the absolute value of all the sections, or all pluses. Depends on how many sections. So, in order to do A and B, I would do them both on the same graph. So, I would graph it first to see what the picture looks like. I'm integrating from 0 to 2. And if you graph this on your graphing calculator, it's going to look something like that on your graphing calculator. It's an upside down parabola from 0 to 2, and I'm going to draw a line there. And they want you to do, again, remember, they want you to find the area from the curve to the x-axis and to the curve to the x-axis. Do you notice that it goes positive and negative? So this is all I'm going to do. I'm going to integrate from 0 to 1, a negative x squared plus 5x plus 4. And then I'm going to integrate from 1 to 2, negative x squared plus 5x plus 4. Again, I'm going to hurry this up, but when you integrate, it's going to be x to the third over 3 plus 5x squared over 2 plus 4x from 0 to 1. Same thing with this one, negative x to the third over 3 plus 5x squared over 2 plus 4x from 1 to 2. Okay, this is going to take a while because what do you have to do? You need to plug 1 in for all the x's. So you need to substitute a 1 in and figure out what that is, minus, then you have to substitute the 0 in. And this will take time. And what you're going to get is a negative 1.83. Then, when you do this, I'm just going to speed this up, you're going to get 1.16, which would make sense. Does that make sense to you? From 0 to 1, wouldn't you get a negative 1.83 because it's below the x-axis? And above the x-axis, you're going to get 1.6. So, I'm going to answer A and B on the same thing. So here's my A, net area, and here's my B, total surface area. So if they ask you to find the net area, you take into account the negative and the positive. When you work this out, you're going to get a negative 0.66 repeating units squared. If they want total surface area, the part that's negative, you're going to change it to positive. And the part that's positive, you're going to stay positive. And when you add that up, that makes 2.99. I think the book has 3, which would make sense. Units cubed. The most important thing is to know the difference between net area and total surface area. Your calculator, if you plug it into your calculator, the calculator will give you net area. In order to get total surface area, the only way to get total surface area is to do it the long way. Any questions? Hopefully, if you have questions, you'll have to stop it and ask me. Okay, last section, last template. These notes take a long time, but they're very important. They want you to find the average value, and you're going to find out why geometry way was really important in 6.2. So, here's what they want you to do. They want you to find the average value of the shaded region, and I didn't shade in the region yet, so I want you to shade in the region. And here is the shaded region. It's this one, and it's this one. So, we need to figure out how to come up with the average value of that shaded region without an equation, because if you have an equation, you could use the integration sign. So, what you need to notice is that there is a perfect rectangle in this picture. And if you subtract, okay, before we get into this, let's label this a -1 and a +1. And this is supposed to be a +1. I'm supposed to draw my rectangle all the way up there. I quite didn't get up there. But they want you to find the average value. They want you to find the average value between a -1 and 1 of this picture. How do you find the average value? It's 1 over the b minus the a. So that's, which is 1/2. So you need that. And then you need to integrate from a -1 to 1. And I don't know what f of x dx is, but whatever this is, we need to multiply by 1/2. But we don't have a function, we just have geometry. So if you took the rectangle and then subtracted it from the semicircle, do you notice that you would get these little things? Are they connected kind of like that? Right? So if you take the rectangle and subtract it from the semicircle, you would get the spot that you would get these little guys. So really quickly, I want to finish up these notes. I want to be done in 40 minutes, so let's get this done. If I want to find the area of the rectangle, you know that this is 2, and you know it goes up 1, so the area of the rectangle is 2. Everybody see that? And if you subtract the semicircle, I know it doesn't look like a semicircle, but if you go out 1 and left 1 and up 1, it's a half a circle. And the formula is 1/2 pi r squared. So 1/2 pi. And you see why it's 1/2 pi? Because the radiuses are all 1. And if you take your calculator and figure out what 2 minus 1/2 pi is, you're going to get 2 minus 1/2 pi is 0.429. What does that mean? It means that this is the area of those two little sections. Okay, this is totally going to make sense what the mean value theorem is. The mean value theorem says to take 1/2 of that. So if you take 1/2 of 0.429, you're going to get 0.215, which is called the mean value theorem. Okay, hopefully, aha, here's the aha. These are identical to each other, correct? So, the mean is the average of the area. It's the average of the area. Does that make sense? That it's the average of the area. The mean value theorem is the average of the area that you find. And if you take 1/2 of 0.429, what do you get? 0.215. It's the average of the two shaded in areas. Hopefully that makes sense on what the mean value theorem is. Okay, the worksheet, don't shut this off yet. The worksheet I'm handing out, you're only doing the circled ones, not all of them, only the circled ones, and the answer key is on the back. Have a good day.